So we're going to spend some time reviewing angles in standard position and trig ratios. This is sort of the end of this little section, and then we're going to be starting sine and cosine law. So let's go through these problems to make sure you're able to do them. In this example, a point on the terminal arm of an angle in standard position is given. So they've given us a point for the terminal arm. So minus 6, 8 is somewhere in quadrant 2. And there's my terminal arm in quadrant 2. They want me to determine the fully simplified exact value trig ratios for angle theta. So that's sine theta, cos theta, and tan theta. And the theta is my rotational angle over here. So what I'm going to do is I'm going to drop this down to the x-axis. If you would like, you could put the -6 on here, the 8 on here. When I'm solving for the hypotenuse, I'm not going to be using any negative signs. The negatives are kind of location indicators. 8 squared plus 6 squared is the hypotenuse squared. So 8 squared is 64 plus 6 squared is 36, so this gives us 100. And h is the positive square root of 100 because we only want to take the positive answer. So h is 10. Excuse me. So this angle here is our theta reference. And in order to find my reference angle, I'm going to take the ratio. Now again, I'm going to kind of highlight this negative sign in a different color because it sort of doesn't exist on my reference triangle. It's kind of helping me know that that angle is in quadrant 2. So I'm going to write my trig ratio. So sine of theta, if I want to do the sine of theta, I can use the -6 in there, the positive 8 and the 10. So opposite over hypotenuse is 8 over 10. Cosine of theta is adjacent over hypotenuse, so -6 over 10. And tan of theta is opposite over adjacent, which is -8 over 6. We need to simplify these ratios. So 8 over 10 is the same thing as 4 over 5. Cosine is 6 divided by 10. That works out to -3 over 5. And tan of theta is -4 over 3. So there's my trig ratios in simplified form. We need to determine the angle of theta. So this is where we want to find our reference angle. I'm going to look at the ratio that's positive for my angle theta. If I use the other two ratios, I want to make sure that I'm not putting in the negatives when I find the reference angle. So theta reference is equal to sine inverse of 4 over 5. You do that in your calculator and you get an angle. Make sure your calculator is in degree mode, and you would get an angle of 53 degrees. Okay, so that talks about my reference angle, and a lot of people on tests, they think, oh, this answer is my answer to the problem, but it actually isn't, because we need to find the rotational angle. And I'm just reading right now, we want to solve it to the nearest 10th. So I'm going to round the reference angle to the nearest 10th. And then to find my rotational angle in red, to go to the full line over here, I would have traveled 180 degrees. And I have to subtract off my reference angle, which is 53.1 degrees. So my theta equals 180 minus 150 minus 53.1. which gives me 126.9 degrees. In the next example, same idea. I want to draw my angle in standard position. This is a negative for x and a negative for y, so we're located somewhere in quadrant 3. Again, I can put the signs on my diagram as long as you know that they're indicating a positional value, not a magnitude value. Like the triangle can't have a side length of -3. I'm going to find the hypotenuse, which is 3 squared plus 6 squared. Again, I can disregard the signs because that's just giving me position. And I get a 45. And then I want to square root both sides, which normally means I do plus or minus. Again, we want our h to be strictly positive, which means I get square root of 45. Now, because my angles need to be in simplified exact form, I need to simplify the square root of 45 using my radicals unit. So square root of 45 is 9 times 5. And so the square root of 9 is 3. And the 5 is left over, so I can write it as 3 square root 5 as the simplified expression for the hypotenuse. Now I'm going to write my angles, my trig ratios for my rotational angle, which is sine theta equals. Now I'm going to include the signs because this is where you'd want to take care of your cast rule, but the signs and the location tell you about the cast rule as well. So opposite over hypotenuse, negative 6 over 3 root 5, which simplifies to negative 2 over root 5. Cosine of theta is equal to adjacent over hypotenuse, so negative 3 over 3 root 5, which simplifies to negative 1 over root 5. And tangent is opposite over adjacent, so opposite over adjacent is negative 6 over negative 3, which is 1/2. Now this also makes sense in terms of my cast rule, because in quadrant 3, my tan is supposed to be positive, which it is, and the other two are supposed to be negative, which they are. When finding my reference angle, I want to choose the positive ratio. So my theta reference is going to be tan inverse of 1/2. And on your calculator, make sure your calculator is in degree mode. And I get 26.6 degrees for that reference angle. So my answer to the problem is my red angle, which is my rotational angle. I've traveled to the 180 degree mark plus a little bit more, which was my reference angle. So if I add that on to 180, I get 206.6 degrees, which is my answer to the nearest tenth of a degree. So this is sort of on our proficiency scale. You're given a point and you have to do the ratios and find the angle. Now what we're going to do is I give you a ratio, I tell you a quadrant, and I want the other two trig ratios. So they've given me tan. I'm looking for sine of theta and cosine of theta. So when they give me tan of theta is 3 over 7, when I look at my cast rule, that's telling me I have to be in quadrant 3 or quadrant 1 because my theta is positive. But then they're giving us more information and saying, okay, we just want you to work in quadrant 3. So I'm going to only work in quadrant 3. I'm going to draw my reference triangle. This is my theta ref. My tan is 3 over 7, so opposite over adjacent is 3 over 7. Now you want to kind of think about the signs associated with this. Because I'm in quadrant 3, this x sort of has a negative positional value, and this y also has a negative positional value. So I can find the hypotenuse, 3 squared plus 7 squared. Again, we don't take the positional value in our calculation. We only take into consideration the values themselves. So I'm going to go ahead. H squared is equal to 3 squared plus 7 squared. Gives me a 58. H has to be positive, so I'm going to say H is only the positive square root of 58. I need to simplify this expression. 58 is 2 times 29, and 29 is sort of a prime number, so we can't really do anything. This H value simplifies to just square root of 58. So we need to think of what is the sine of my rotational angle theta, which again takes into consideration positional values. So my positioning for sine makes the sines opposite over hypotenuse with a negative sign on the 3 because that's kind of in a negative positional value. Cosine of theta is my opposite adjacent over hypotenuse, which is -7 over root 58. That also makes sense in terms of the cast rule because sine and cosine would be negative in quadrant 3. Now we need to do the exact ratios for angles, and this time all I give you is an actual angle, and these are special angles because they have the reference angles of, so as soon as they say special triangles, they have reference angles of 30, 45, or 60 degrees, and when they say special triangles, I'm going to come back and use kind of the finger hand trick where there's a square root over your fingers and then your palm, and again it's your right hand facing you. So the first thing we need to do is take my angle that they give me, find the reference angle for the given angle. So there's 150 degrees, which means to get to 180, my reference angle would have to be 30 degrees. So once I've located what angle is required of me, I'm going to use my finger trick or my special triangles, which again, I've already forgotten by now. Well, no, I haven't forgotten, but they're easy to forget. I want to locate my 30-degree finger. So this is 0, 30, and I'm going to bend that finger down. Okay, that finger gets bent down, and I'm looking for the tan of the 30 degrees. So I need to count the sine fingers, which is 1. So root 1. I need to divide that answer by the cosine fingers, which are 1, 2, 3. So root 3, and that value represent my tangent of 150 degrees. But, well, actually, sorry, we should be careful here. This represents the tan of 30 degrees. So in order to get the tan of 150 degrees, I need to think of cast. And my cast rule tells me that in quadrant 2, tan would be negative. So I'm just going to use a negative root 1 over root 3, which simplifies to -1 over root 3 as my final answer. Okay. When I'm looking at 240 degrees, I'm going to draw my 240 degrees. So 240 is somewhere here. I'm interested in finding my reference angle, which is this angle right here, theta ref. So my theta reference would be the difference between 240 degrees and my 180 degree line. That difference is 60 degrees, so I'm looking at my 60 degree reference triangle or my finger trick at 60 degrees. So there's the imaginary 2, there's my palm. 0, 30, 45, 60. This is the finger that gets bent down. So there's my finger that gets bent down. I'm interested in the sine of that position. So sine of 60 is equal to, I count my sine fingers, 1, 2, 3. So square root of 3 divided by my palm, which is 2. And then in order to get the actual sine of 240 degrees, I'm looking in quadrant 3. And in quadrant 3, tan is positive, so sine would be negative. So that would be my final answer. So this question, hopefully you'll recognize to use the special triangles because they only give you an angle and then they don't give you any other information. Now over here, when we're doing this example, we're sort of working backwards. I'm giving you the value of the ratio, and you're going to give me the angles that cause those ratios. Now, in this first example, what I want to do is I want to figure out if this shows up on my fingers or my special triangles. I do recognize that value on a special triangle, but when I do rationalizing to get rid of the radical on the bottom, my numerator would be 1 times root 2, which is negative root 2. And then root 2 times root 2 is 2. So I get a value that I remember on my fingers. So what I'm going to do is I'm going to put my fingers in front of me. And I can't actually put it in front of you in this video, so I'm going to show you through the hand. I want to make sure that my cosine side has 2 fingers. So I'm going to locate 2 fingers on the left-hand side because that's where cosine is. And then I'm going to figure out which finger I have to put down in order to get a root 2. So 2 fingers over 2, which means 0, 30, 45 degrees is my reference finger that was put down. So once I locate my reference angle, I write my cast rule down and I want to locate the quadrants that have a negative cosine value. So S would have a negative for cosine and T would have a negative for cosine. So I'm going to draw my 45-degree reference in quadrant 2, and I'm going to draw my 45 reference angle in quadrant 3. And my goal is to look for these rotational angles that are causing that 45-degree angle. So in this case, it's 180 degrees minus the 45, which would give me 135 degrees. And in quadrant 3, I go to the 180 line plus my 45 degrees, and I get 225 degrees for that. So those would be my answers to the problem. Is 135 degrees and 225 would produce a cosine value that is negative, and the value of that ratio would be 1 and a root 2. Now when I'm looking at this question, this is not off a special triangle, nor is it on my fingers. So to get my reference angle, I need to use my calculator and ignore any negative signs. I'm going to do sine inverse of just the positive numbers of whatever is shown, and that would give me my answer. So if I do second sine of 4 over 5 on my calculator, I get 53 degrees. And for this question, I'm just going to round to the nearest whole number. So 53 degrees. Same idea. I use my cast rule once I have my reference angle to locate the 2 quadrants where sine is positive, which is quadrant 1 and quadrant 2. My answers, one of them will come from quadrant 1 with a 53-degree reference angle, and one of them would come from quadrant 2 with a 53-degree reference angle. My rotational angle is demonstrated in orange. So in this case, my theta is the 53 degrees. And in the second case, it's 180 minus 53 degrees, which is 127 degrees. And that would be my final answers, the 127 and the 53. Hopefully you feel comfortable with this. I will post more review in the D2L shell so you can practice some more. And we're kind of done with the right angle trig. Starting Friday, we're going to work on trigonometry again, but we're going to have triangles that don't have the 90-degree angles in them. So we can't use Pythagorean theorem, we can't use SOHCAHTOA, we can't do any of the trig that we're already used to. And we're going to learn 2 brand new ideas. One of them is how to solve the triangle using sine law and how to solve the triangle using cosine law.